Okay, so we are solving question number 18. The vapor pressure of a dilute solution of a non-volatile solute and the vapor pressure of the solvent at the same temperature are P star respectively. Then P star minus P by P star is equal to, we have to choose the correct option. So we have to solve this. So what do? We write P A equals to xi A, or rather let's say this way. A is the solvent and B is the solute. So we can write P equals to xi A P star, or we can write P equals to 1 minus xi B P star, or we can write P equals to P star minus xi B P star, or we can write xi B equals to P star minus P by P star. So we can see that P star minus P by P star is equal to the mole fraction of the solute. That means XB. So D is the correct answer over here. Okay, now over here we have 19. The volume of water in ml required to be added to 100 ml solution of aqueous zero point 0.1 molar of weak acid HA at 25 degrees centigrade is double its degree of dissociation. Okay, and we have been given the Ka value of Ha at 25 degrees centigrade to be as 1.8 times 10 to the power minus 5. So we know alpha, the degree of dissociation, is K suffix A by C. So when the degree of dissociation is double, we will say it is K suffix A by C prime, or we can say alpha square equal to K suffix A by C. 4 alpha square equals to K suffix A by C prime. Okay, or from these two equations we can write that for K suffix A by C equal to Ka by C prime, and then we can say C prime equal to C by 4. Okay, now let us assume that V1 is the initial volume and C is the initial concentration, V2 is the final volume, and C prime is the final concentration. Okay, so in place of C prime we can write C by 4, that is equal to V1 C. C and C gets cancelled. Okay, so V2 becomes V1 times 4, which is equal to 400 ml, because V1 given to us is 100 ml. So V2 minus V1, which is the amount of water that should be added, will be equal to 300 ml. So answer over here will be 300. Now the following diagram is obtained in a pH metric titration of a weak dibasic acid with a strong base. The point that base describes concentration of Ha minus equals to A2 minus will be obviously this point, which is R. So answer will be C.